Hello friends, welcome to my channel. Today we are going to do KEAM 2017 important questions of physics and chemistry. This will be a playlist containing important questions of KEAM 2017. So let us get started. From the ground, a projectile is fired at an angle 60 degree. Theta is equal to 60 degrees. The horizontal with speed is equal to u is equal to 20 meter per second. G is equal to 10 meter per second. We need to find the range. R is equal to u square sine 2 theta by g, which is equal to 400 into sine 2 theta is equal to 2 sine theta cos theta, which is 2 sine 60 cos 60 by g, which is 10. We can cancel this, which gives us 40 into 2 into root 3 by 2 into 1 by 2. So we get 20 root 3 meters as the range. Okay. A body of mass m is moving with a velocity v. So a body of mass 2m is moving with a velocity v and makes a head-on collision with another. So let us consider this to be 2m and hits another particle, okay, which is initially at rest. Okay, it is at initially at rest. Finally, when this collides, 2m will have some velocity and m will have another velocity. Okay, so we need to find the loss of kinetic energy of the colliding body. So in this problem, the body possesses conservation of momentum and conservation of kinetic energy. So initial momentum is equal to final momentum, and similarly initial kinetic energy is equal to final kinetic energy. Okay, so if we write down the equations, we get 2m into v is equal to 2m v1 plus m v2, and similarly half into 2m into v squared is equal to half into 2m into v squared v1 squared plus half into m into v2 squared. Okay, so from here we can cancel m, which gives us v2 is equal to 2 into v minus v1. From here we can cancel half m. Okay, so we get 2v squared is equal to v1 squared 2v1 squared plus v2 squared. Now if we substitute the value v2 here, we get 2v1 squared plus 4 into v squared plus v1 squared minus 2v1 v1. Okay, we get this. So we get 2v squared is equal to 2v1 squared plus 4v squared plus 4v1 squared minus 8v1. Okay, now if we take everything to one side, we get 0 is equal to 6v1 squared plus 2v squared minus 8v1. Okay, now if we divide the both sides by v1 squared, we get okay. Now this we can cancel v1 squared 2v1, and here we can cancel v1. So here we are in insufficient space, we need to add more space. So we got 0 is equal to 6 plus 2 v by v1 squared minus 8 v by v1. Here we can do this 2 into 4 v1 v1. Okay, now let us consider v by v1 to be t. So we get 6 plus 2 into t squared minus 8t. Okay, now if we solve this, we get v1 is equal to 1 by 3 v. Okay, so k2 will be equal to half m okay final is equal to half m v final squared, which is equal to half into m into half into 2m into v1 squared, which is equal to 1 by 2 into 2m into v square by 9, which is equal to mv square by 9. Okay, so the initial kinetic energy is mv square by 2. So we get the change in kinetic energy or the lost energy is equal to 8 by 9 mv squared. Okay, sorry, mv square is the initial kinetic energy, finite kinetic energy is mv square by 9. So we get the loss of kinetic energy to be 8 by 9 mv squared, which is equal to 8 by 9 KEI. Okay, now let us move to the third question. Please note every questions in your book, because each and every questions are important, which I am telling you. Displacement x of a body of mass m1 kg is given as x is equal to 2t square. The work done in the first 1 second by the external force is equal to. So we are given x is equal to 2t square. So v is equal to 4t. So for t is equal to 0, v is equal to 0, and for t is equal to 1, v is equal to 4. Work is equal to change in kinetic energy, which is equal to KEF minus KEI. Okay, so KEF is equal to half into m which is 1 into 4 squared minus half into 1 into 0 squared. This is equal to 16 by 2, which is equal to 8 joules. Okay, so the total work done is 8 joule. Now the fourth question, the copper wire. It's copper wire with a cross section of area 2 into 10 raised to minus 6 meter square, has a free electron density of 5 into 10 raised to 22. If the wire carries 16 amperes, then the drift velocity. So we know that J is equal to nqv. Here J is the electron. Here V is the drift velocity, Q is the charge, and N is the electron density. Okay, and J is the current density. So this can be written as I by A is equal to N into E into Vd. So we need to find the drift velocity. Drift velocity will be equal to I by NEA. So here I is equal to 16 by electron density is equal to 5 into 10 raised to 22 into E is equal to 1.6 into 10 raised to minus 19 into A is equal to 2 into 10 raised to minus 6. So here 10 raised to 22 minus 10 raised to into 10 raised to minus 19 is 10 raised to 3. 10 raised to 3 into 10 raised to minus 6 is 10 raised to minus 3. Here 5 into 2 is equal to 10. 10 into 1.6 is 16. So we get 10 cube meter per second as the drift velocity. The resistance of W wire. W means tungsten wire in the light bulb, which is 120 volt, 75 watt, and powered by 120 volt direct current supply. So we need to find the resistivity. Okay, so R is equal to V square by P. Okay, so this is equal to 120 into 120 by P, which is 75. Okay, now this is equal to, if you divide by 5, we get 24. This, if we divide by 5, we get 15. Now this will be equal to 24, which is 8, and this 5. Again this and this will go 24. So 24 into 8, 32, 16, 192. So 192 ohms. Okay, the sphere of radius r has a uniform volume charge density rho. The magnitude of electric field at a distance r from the center of the sphere where r is greater than r is. So in this question it is given that E is r greater than r. Okay, so this will be equal to rho by 4 pi r cube, 4 pi epsilon naught r cube. Now if we divide and multiply it by r cube, we get rho r cube by, and if we multiply and divide 4 by 3, we get 4 by 3 pi r cube into 3 epsilon naught r cube. Okay, this is equal to rho r cube, rho r cube by 3 epsilon naught r cube. Okay, so this is the answer. 5 equal charges with q is equal to 10 nanocoulomb are located at x is equal to 2, 4, 5, 10 and 20 meter. If epsilon naught is equal to 10 raised to minus 9 by 36 pi farad per meter, then the potential at the origin x is equal to 0 is. So we must be knowing that the equation for the potential of electric field is kq by r. V is equal to kq by r. Okay, so we need to find the resultant potential, which is V is equal to V1 plus V2 plus V3 plus V4 plus V5. This will be equal to 1 by 4 pi epsilon naught into q into 1 by 2 plus 1 by 4 plus 1 by 5 plus 1 by 10 plus 1 by 20. This is equal to 99 volt. Okay, if you solve this, we will get, I don't have much time, that's why I'm not doing the calculations. Okay, now let us move to the to okay, this